What is dough mixing? Dough mixing is a process in which flour and water are mixed until gluten is developed, a result of the enhanced interaction between dispersed and hydrated gluten-forming proteins. It's quite different from batter mixing due to differences in their respective formulations, specifically, the proportion between dry and liquid ingredients. The goal is to incorporate air, hydrate dry ingredients, homogenize the dough by evenly distributing all the ingredients, knead the dough, develop the gluten. How does it work? Dough mixing can be viewed as a simple reaction in which the reactants transform into a homogeneous and aerated dough, for example. Flour combined with water combined with air combined with energy, or work, becomes dough. The mixed dough consists of continuous, gluten, and discontinuous or dispersed, air cells, phases. Ideally, this mechanical process creates a viscoelastic mass that has optimum dough handling properties and gas retention capacity, essential for product expansion during proofing and oven spring. Dough formulations that fall into the dough mixing concept should meet the following conditions. Use of flour from hard wheat. All-purpose and soft or hard wheat flour blends can also be used. Hydration levels of 50 to 70% depending on the presence of bran, amount of protein and degree of starch damage in the flour. Flour and water, combined, usually represent more than 70% of total formula weight for rich and sweet doughs, and at least 90% of formula weight for lean doughs. Why is dough mixing important? Mixing is a crucial step in all dough systems used for the manufacture of yeast-leavened baked goods. It is critical to obtain the right rheological properties and consistency of the dough for the production process to run smoothly, as well as achieve the desired finished product quality. In sponge and dough systems, the sponge is mixed first and then ferments. The second mix is dough mixing, where the objective is to develop the gluten. In straight dough and no-time systems, dough mixing happens only once. In continuous mixing dough systems, the first mixing is a blending step, which is not intensive in nature. The goal here is to distribute and incorporate ingredients evenly. After a set time in a fermentation and holding tank, a second mixing step occurs. This is mechanically intensive, since the goal is to develop the gluten. Stages of dough mixing. First, pick up, dough is sticky, cold and lumpy. Second, initial development, dough gets warmer, smoother and drier. Third, clean up, dough is at maximum stiffness and comes together as one cohesive mass. Fourth, final development, dough is at the correct temperature and handling quality, gluten film is visible, and the dough is ready to be discharged from mixer. Fifth, letdown, the gluten matrix begins to degrade. The dough is too warm and sticky, lacks elasticity and has too much flow. Sixth breakdown, dough is beginning to liquefy. At this stage, the dough is not salvageable and cannot be used to make bread. Excessive mechanical energy and shear break down the relatively stable molecular interactions between gluten-forming proteins such as disulfide bonds. This causes depolymerization of large gluten aggregates. In this stage, the dough becomes a fluid and viscous mass, with minimum or no elasticity, that has lost most of its water-holding capacity. As a consequence, most of the retained water is released and dough becomes excessively sticky. Application. Different mixers can be used in making bread dough. Capacity, pounds of dough per hour, energy consumption, rotations per minute, RPM, acquisition costs, level of process control, and hygienic design are some features that high-speed bakers often consider when buying dough mixing equipment. Common dough mixers include continuous mixer, horizontal mixer, spiral mixer and Tweedy or Chorleywood bread mixer. The addition of salt, sugar and fat should be delayed to reduce dough mixing time. This helps gluten proteins hydrate and develop quickly, cleanup stage takes much less time, and provides maximum friction against mixer bowl. Mixing is an intensive mechanical operation that produces heat from friction. This is evidenced by the temperature increase in the mass being transformed into dough. For proper machining during makeup, a final dough temperature should be close to 76 to 82 degrees Fahrenheit, 25 to 28 degrees Celsius. To assess if the dough is properly developed, perform the gluten film test. A small portion of dough is stretched between the hands into a thin, smooth, translucent film to test its extensibility and elasticity. Want to learn more about dough mixing, including the relationship between mixing stages and dough status, as well as how to tell if dough is over or undermixed? Visit BAKERpedia. Learn more about all things baking by signing up for our newsletter. Until next time, bakers. At BAKERpedia, we're here on a need-to-know basis.